At this lab station, you're going to investigate the angle of sunlight and how it affects temperature. You're going to start by copying this data table into your journal. There's rulers for you. Do make sure that you give it a title. Describe the information. Do this part quickly because you only have 10 minutes at the station and it goes quick. Once you have this recorded in your journal, here's what you're going to do. The time 0 is the temperature of both the equator and the North Pole before you turn the lamp on. That's important to record before you change anything. You're going to make sure to look at the bigger number on the thermometer, which is your Fahrenheit temperature. And there'll be a little colored bar to indicate the temperature. For example, right now it's 72 degrees in both locations. Once you're ready, you're going to coordinate with your group. You have one person that's allowed to use a smartwatch or a phone as a timer. 3, 2, 1, go. Start your timer. Turn the lamp on. The lamp is a heat lamp. It gets hot. Don't touch it. It's hot. You're going to wait for 1 minute. After a minute is up, record the temperature at both locations again. Write it in your data table. Keep your timer going. At the second minute, do the same thing. After 2 minutes are up, record your temperature in both locations. And then, super important, turn your heat lamp off immediately. The setup takes a while to cool down, and the next group needs to have it cool down in order for them to wait. While you're waiting, part 2 of your lab. You're going to use a flashlight to simulate sunlight hitting different parts of the planet, and I'm going to show you how it's going to work. This is just going to go on the bottom half of the same page in your journal. You're going to take a flashlight, and you're going to hold your flashlight directly above the paper, and you're probably going to hold it an inch or so above, pretty close, and you're going to see there's a concentrated, dark, bright circle. You're going to do your best to circle that or just trace that circle. It doesn't have to be perfect. When it's hitting the paper directly like that, as in a 90-degree angle or perpendicular, that's modeling when the light from the sun is hitting the equator. Because the Earth is a sphere, the sunlight hits the equator directly, and that sunlight all gets concentrated in that area, which means it's really strong, and that's why we get warmer temperatures. The poles, because we're a sphere, we're not a flat Earth, that poles and that spherical shape means that we're going to heat differently. Even though it's the same flashlight, notice when it comes in at the North Pole, it's coming in at an angle or indirectly, and that light spread out over a larger area. And so on your paper, you're going to do the same thing. You're going to hold it really close and then tilt it so you can see that larger area on your paper. So this one is like the light at the equator. It's strong and concentrated. This one is like the light at the poles. It's the same amount of light, but it has to spread out over a greater area. That's why we have warmer temperature at the equator and cooler temperature at the pole. You're going to make sure that you label direct light equator. So you're going to write that right there. And then you're also going to label indirect light poles, and you're going to label that under that circle. When you're done, make sure you're respectful of the materials and the batteries. Turn the flashlights off. Put all your materials back in the bins before the 10 minutes is up so you can share your station with other people.